Hello and welcome to today's session. This session focuses on assignment discussion, additional organic chemistry. In this video, we will explore key concepts essential for advanced studies in medicine. From optical isomerism to interpreting spectroscopic data, you will gain the understanding and precision required to tackle complex organic chemistry topics and excel in your assignments. This assignment is designed to enhance your understanding of organic chemistry. The focus is on individual written work with a word count of up to 2,000. Grading follows Ascentis standards with 3 levels. Accurate chemical reasoning is crucial. Diagrams and equations are essential for high grades. The assignment covers 3 main learning outcomes. Understanding optical isomerism is the first. The second is comprehending benzene rings. Lastly, interpreting spectroscopic data is essential. Each outcome requires detailed explanation and application. Optical isomerism involves chiral carbon atoms. Enantiomers affect plane polarized light differently. D+ and L- forms exhibit optical activity. Racemic mixtures are optically inactive. Understanding these concepts is vital for drug design. Thalidomide's history highlights enantiomer importance. Teratogenic and therapeutic forms differ significantly. In vivo, racemization can occur. Optical purity is crucial in drug design. Current uses of thalidomide are strictly controlled. Benzene's molecular structure features a delocalized pi electron system. This planarity results in equal C-C bond lengths. Bond angles are 120 degrees. The real structure contrasts with Kekulé's model. Understanding benzene's stability is key. Calculate benzene's enthalpy using the Kekulé model. Compare it with experimental values. Delocalization energy explains benzene's unusual stability. This impacts its reactivity. Linking structure to reactivity is essential for understanding. Spectroscopic data helps identify unknown molecules. Use IR, mass spectrometry, and NMR data for analysis. Identify functional groups from IR spectra. Molecular ion and base peaks are key in mass spectrometry. Proton NMR provides chemical shifts and splitting patterns. Key absorptions in IR spectroscopy include OH and CH bonds. Carboxylic acids absorb between 2,500 and 3,200. Aromatic CH absorbs from 3,000 to 3,100. Aliphatic CH is between 2,850 and 2,950. Understanding these absorptions is crucial for analysis. Mass spectrometry reveals molecular ion peaks. These peaks indicate relative molecular mass. Base peaks highlight fragmentation patterns. Identifying alcohol fragments like CH3O+ is essential. Linking fragments to structure aids in molecule identification. Proton NMR uses chemical shift values in delta ppm. Integration reveals proton environments. The N+1 rule explains splitting patterns. Triplet, quartet, and singlet patterns are common. Linking spectra to molecular structure is crucial. Grades depend on explanation, accuracy, and depth. Grade 1 requires accurate concept explanations. Grade 2 demands good application of theory. Grade 3 requires excellent interpretation and reasoning. Correct mechanisms are essential for higher grades. Using correct chemical notation is vital. Diagrams and data must be properly referenced. Harvard referencing is required throughout. Plagiarism and malpractice are strictly prohibited. Adhering to scientific conventions is essential. Clayton et al.'s organic chemistry is a key resource. McMurray's Organic Chemistry offers additional insights. chemguide.co.uk provides useful online materials. OCR, A-level chemistry resources are recommended for spectroscopy. Peer-reviewed texts ensure reliable information. Optical isomerism significance extends to drug design. Chiral molecules interact uniquely with biological systems. Enantiomer purity affects drug efficacy and safety. Understanding racemic mixtures is crucial. This knowledge is vital for pharmaceutical advancements. Benzene's stability affects its reactivity patterns. Delocalized electrons reduce typical reactivity. Electrophilic substitution is a common reaction type. Understanding this reactivity is key in organic synthesis. Benzene's unique properties influence its chemical behavior. Spectroscopic techniques are essential for molecule identification. Each technique offers unique insights. Combining IR, MS, and NMR provides comprehensive data. Accurate interpretation is crucial for correct conclusions. Mastery of these techniques aids in chemical analysis. Conclusion: mastering these topics provides a robust foundation for advanced study and further academic development. This understanding equips learners with the essential knowledge and skills necessary to progress confidently in their future learning. For support or questions, reach out via WhatsApp at 07484361688. We're happy to help. Thank you and see you in the next session.